is 2 times, and I like putting the parentheses in, m to the 9th p to the 6th minus 3m squared times, oh, there's a p in there, right? 4th root of mp squared, like this. Now, you can't just subtract them because what's under the radicand is not the same, correct? You need to simplify it in such a way that maybe you either turn this into this or vice versa. Which one do you want to work on? Do you want to work on this one or that one?
The first one.
The first one. At higher powers, they might break up a little nicer. So the idea here is you can go straight to the power, or you can try to find for things that you can pull out nicely. Things that you can pull out nicely. So for example, does the 9th power have a nice 4th root?
No.
It doesn't, but what's really close to 9 that does?
M to the 8th.
M to the 8th does, right? So you could rewrite this as the 4th root of m to the 8th times the 4th root of m times the 4th root of p to the 4th times the 4th root of p. Why did I do that? M to the 8th and m is just m to the what? 9th. And then to the, oh, that's going to be p, sorry, squared. Like this, right? Is that correct?
What about the p to the 6th? How'd you get?
We got p to the 6th because it's 4 and 2, right?
Okay.
The reason I did that is because what does this break down to? That's 2m squared, right? Because what is the 4th root when you have it to the 8th power? 8 divided by 4 is 2. And then here we have the 4th root of p to the 4th. What's that going to be? Just p, because what's 4 divided by 4? 1. And you're left with the 4th root of m, and you're left with the 4th root of p squared. But you can recombine those. And if you recombine them, you end up with 2m squared p times the 4th root of what? Oh, and is that what you wanted? Yeah, you end up with what? Minus what? 3m squared p times the 4th root of mp squared. Now can you combine them? Sure, you have 2 of them and you're subtracting 3 of them, so what do you end up with? Negative, yeah, like this, right? Okay, so we'll do this again. Over here, did you understand how we got to the red line? All of this in red.
Yeah.
Okay, so what is the 4th root of m to the 8th? M squared. So that's why there's m squared. This turned into m squared. What's the 4th root of p to the 4th?
P to the 4th.
It's p.
No, it's just p.
It's just p, correct. It's just the p. That's not p to the 4th. Let me just make this a little clearer. This is to the 4th power right there. So this one came from there. So what are you left with? This is still left. We can't simplify that, right? That's the 4th root of m. And this is still left. It's the 4th root of p squared. So both of those are still left right here. So now what do you have? You have 2 times this, and you have negative 3 times that. So can you combine them now?
Yeah.
Look, you have, ready? M squared and m squared. You have p and you have p, and you have the 4th root of what? The same thing. So can you combine them? Yes, you have 2 of them, and net you're taking away 3 of them, so you have negative 1 of them. In this case, them is this thing right there at the bottom.
Oh, okay.
You see?
Yeah.
To solve that, what would you need to do first?
Could you just
Solve for x.
Yes, we're solving for x. That's our goal. But what's our first step for trying to solve for x? We need to get rid of the square root, so how can we do that? The first word that you really need to remember is you need to isolate the radical. In this case, is the radical isolated? It is. There's nothing in front of it. So now you're going to do this square both sides. And this is important. You are going to square both sides. Sides. It's really important. Sides. No. What is the square root of 3x plus 4 squared? What happens? It just turns into 3x plus 4. The square root of a table times the square root of a table is? A table. What does the right side become? So 3x is equal to?
64.
X is equal to? 20. The last step, what do you always do last? This is important. I've always said to do this, and sometimes we're a little lackadaisical about it. It's really important that you check now, because when you square things, it is very easy to make false answers. Here's why. Kelly, is this true?
No.
Is this true?
Yeah.
Yeah. So it's possible if you don't see something as being unequal and then you square it, you can make things equal that weren't equal to begin with. So you always have to check your answer. How do we check our answer on this one? You plug in 20 into the left and see if it equals the right. Don't do both sides. So you have the square root of 3 times 20 plus 4. That's equal to the square root of 60 plus 4, which is equal to the square root of 64, which does equal what? So it does check. So let's add in just a little bit more to this. What happens for round 2? For round 2, let's say I asked you the square root of 5x minus 1 plus 3 equals 0. What should I do first? What was that first word?
Isolate.
Isolate the radical. Is the radical isolated? No. So what should I do? So you get the square root of 5x minus 1 is equal to square both sides, and you get what? Equals. So 5x is equal to 10. I can almost do basic math. Almost. It's okay. I'm now stuck here. Sure, I'll open snag it and then go away. It's 10. So what does x equal? 2. So what should you do?
Check.
You need to check. It's really important that you check. So what do you end up with? The square root of 10 minus 1 plus 3, which is the square root of 9 plus 3. Oh, wait. What's the problem? What's 3 plus 3?
6.
So guess what? This is not an answer. So what's the answer to this question?
No solution.
This is the first really important thing for today, is that when you have the square root of something, you get the principal root, which is the positive root. If I just ask you if I said square root of 9 equals, the answer to this is 3. But, Kelly, if I asked you x squared is equal to 9, what's the answer to this?
3.
Or negative 3. This is a different question. X squared equals 9 is a different question for me asking you square root of 9, what does that equal? What I'm saying is if I just gave you square root of 9, the answer is 3, the principal root. So going over here, the square root is, you see how it's already part of the equation? So what is the square root of 9 equal to? 3. So does this check out? It does not. On the test or quiz or whatever I give you, you have to do the work and check it and show that it does not work to receive full credit on something like this. So we're just going to ramp it up a little bit more. So here's question number 3. How about you check this one? The square root of 4 minus x equals x plus 2. Try this one on your own and see what you... So what do you get on the left? You get 4 minus x, right?
Yeah.
So on the right it's going to be x squared plus 4x plus 4. What cancels from both sides?
Oh, it's not difference of squares. That's not.
So you get 0 is equal to x squared plus what? What can you factor out of this? So you get 0 is equal to x times x plus 5. There are two potential answers. X equals 0 or negative 5. Negative 0. When we check that one, you end up with 4 minus negative 5. Does that equal negative 5 plus 2? What's 4 minus negative 5? 9. Does that equal negative 3? Does 3 equal negative 3? Does 3 equal negative 3? No. So the only answer is 0.
Oh my gosh, I was right.
Nice. Try that one for me. Be careful. Which one should I subtract?
3x plus
Yeah, I like that. Sure, that's a great idea. I don't like having two radicals on one side. It just seems like having two on one side. At this point, what's the only thing we really can do?
you can square them.
You have to square both what?
Both rad.
No, both what? Sides. You have to square the sides. So let's look at the easy side. Which side's nicer, the left side or the right side? The left side. What does the left side multiply out to? 5x plus 6. But what does squaring mean? It means you take the first thing and you multiply it by itself, right? Does that help? Oh, good job. So look, you're going to end up with 5x plus 6 equals what? 4 minus 2 root 3x plus 4 minus 2 root 3x plus 4 plus what? 3x plus 4. Can you take a look at too fast? 2 times 2 is 4. 2 times that one is minus 2 root 3x plus 4. But then you do this one and you get the same thing. Minus 2 root 3x plus 4. But then the last one, what's the last thing you have to do? You have to multiply this by that. So you end up with plus negative root 3x plus 4 times negative root what? 3x plus 4. But what's the square root of a table times a table? A square root of a table times a square root of a table is itself. So you end up with 4 minus, you have negative 2 of them and negative 2. So how many total do you have? You have minus 4 of them. So you end up with 4 minus 4 root 3x plus 4. And then what does this become?
Plus 3x. Or
3x plus 4.
3x.
Negative times a negative is a positive. The square root of a table times the square root of a table is a table. Are we done yet, though? No, but can you tell me what was that first word that you need to do when you have a radical equation? Isolate. So guess what you can do now? This kind of looks worse, but can you tell me why that is a lot better than what we started with? What's the key difference between what we started with and what we have right now? One radical. Exactly. So isolate the radical for me. Go ahead. Isolate this. What do you end up with? Well, you have 4 and 4. So that becomes what? What's 4 plus 4? 8 minus 4 root 3x plus 4 plus 3x. And you still have this on the other side. How many x's should I subtract from both sides?
3.
Yeah, good answer. Very clear. So I subtract that. And how much? Let's subtract the 8. So what do I end up with? 2x minus 2 equals negative 4 root 3x plus 4. Now, have we isolated the radical yet? No. What number could we multiply? What number could we divide by to make things a little nicer? Let's divide by negative 4. Or let's just divide by 2. Is that okay? Could I divide by 2? Is that okay? It's okay. So what do I end up with? X minus what? 1 is equal to negative 2 times this. Right? We just divided by 2. Divide by negative 2. So what do you end up with? Yeah, x minus 1 over 2 is equal to, divide by negative 2, this. Are we okay so far? What do you think? Is this isolated? Isolated? Yup. So at this point, what do we do? What's that one word?
Square.
Both sides. The square both sides. So if we square the right, what happens? What does the right-hand side become? Just 3x plus 4. The left hand becomes x minus 1 squared over what? What is minus 2 squared? I'm just doing a little bit out here. Now, if we're solving for x, what type of equation do we now have? What's the highest power of x in there? So it's something with the q?
Quadratic.
This is a quadratic, right? So we need to multiply this out and set it equal to what?
0.
0, exactly. We love this. So what should we multiply both sides by? 4. X minus 1 squared is equal to what? 12x plus what?
16.
And then what do we have to do to the left side? We have to do what?
Distribute.
We have to distribute it out. It's going to be x squared minus 2x plus 1 is equal to 12x plus what?
16.
We need to set it equal to 0, so let's subtract 12x from both sides. And what else should we subtract? 16? So what do we end up with? X squared minus what?
14.
Minus equals. And at this point, what's that one word we love? It begins with an F? Factor. Exactly. So this one's actually kind of nice because what's the coefficient in front, Katie? No, it is. What is it? It's 1. We love that, right? It's the easiest type of factoring, and hopefully it's nice and not prime. Well, we're looking for two numbers that multiply together to get negative 15, but add together to get negative 14. X what and what? 15 and negative 1? Well, 15 plus negative 1 is and x plus 1. So what are the two answers? 15 and? So these are the two possible answers. All of that work was to get the possible answers, and this is most of the work, but what do you have to do at the end here? See if they both work. So you go back up here, you go back up to your original equation, which is right here, and I know it looks like a ton here. You have to see when you plug all this in, and I'll get it right here, when you plug in those two numbers, does it come out to be 2? This is what we're checking right here. We're checking this to see if it equals 2. Which one do I want to plug in first, 15 or negative 1? Sure. So let's try x equals 15. So you get the square root of 5 times 15 plus 6 plus the square root of 3 times 15 plus what? What's 5 times 15? 75. 75 plus 6? Plus the square root of 49. Well, that's 9 plus what? Does that equal 2?
No.
So that is not this one.
Well, that you said equal to, not 10.
Does it equal 2? No, it equals 16. So does it check?
Oh.
Does it check? No. So what's the other side we have to check? We have to check x equals what? Negative 1. So if we try negative 1, you end up with the square root of negative 5 plus 6 plus the square root of what? Negative 3 plus 4. What's the square root of 1 plus the square root of 1, which is 2. So does it check? So what's the only answer to this? So this one is the one you like right there. You could get, when you do all the work correctly, you could get 2 answers. One of them could be correct, 2 of them could be correct, or none of them. You're not guaranteed to have any sort of statement. The reason is when you square things, it is really easy to generate false answers. It's really easy to generate false answers because it just can happen.
Is that how long we do?
Let's do both. We'll do both. What do you do first here?
Square.
Yeah, 9 minus x is equal to x squared plus 6x plus 9. Are you okay with that?
Yeah.
You have to set it equal to what? Oh, but what can you cancel?
No.
So you end up with 0 equals x squared plus what? So 0 is equal to x times x plus 7. So x is equal to 0 or what?
What was that step?
I factored.
-7.
Okay.
-7.
How do you get to 0 and -7?
Ah, so you understand where the 9s went away, right?
Yeah.
I added x to both sides. So that's why it became 7x.
How do you get the x to the other side without making it negative?
It's negative x, so how do you get rid of it? You add x to get rid of a negative x.
Yeah, but you have
6x.
you already added the x. I'm talking about at the end. Where
At
it
the
goes
end?
0 equals x.
Okay, are we okay? Let me clarify. Are you okay with this right there?
Yeah.
Okay, I factored. What's in both of these?
An x.
So I pulled them out, and I end up with x times x plus 7.
Yeah, but then you put the x on the other side, and it's not.
I'm not putting it on the other side. I'm using the zero product rule. You have 2 things that multiply together to get 0. So one or both has to be 0.
Oh, okay.
So how do you make x 0? Well, you make x 0 by making x equal to 0. How do you make x plus 7 equal to 0? -7 is what x is. So I used the zero product. That wasn't algebra right there.
Okay.
So what do you have to do now, though?
Check.
Check it. Let's check 0 first. The square root of 9 does equal 0 plus 3. Is that true? Yes. What about -7? 9. What is 9 minus -7 equal to? 16. So that's what? 4. But what's -7 plus 3? -4. So are they the same? No. So what's the only one? 0. Keep in mind, is it possible for both to be true? Could, theoretically, I come up with 2 answers?
Yeah.
Yes. So just because you get 2 and one doesn't work doesn't mean the other one will. You have to test both.
So we have to test 0.
Yes, and -7. We just did, right here.
Yes.
So on the next one, though, what do we like to do first on this one? What was that nice first step, Rachel, that maybe you did?
I isolated one.
Yeah, you isolated one. So how about we isolate the r plus 6? I mean, could you theoretically isolate the other one? Why did I choose that one instead of the other one?
Because it's,
I like positive things.
yeah, positive.
That's it. Now what's the only thing you can do? 3 words. Square both sides. So what does the left side become?
R+6.
And on the other side, you end up with 4 plus 4 of these plus r minus 2. I just skipped a lot of steps there, but that's what you end up with because when you square both sides, you have to take this and multiply it by itself. So when you have that, you have 2 plus root r minus 2 times 2 plus root r minus 2. What's 2 times 2? 4. And then you have 2 times root r minus 2 and 2 times it, so that becomes what? 4 of them. But what is the square root of r minus 2 times the square root of r minus 2? A table. Right? So now, how many radicals do we have? Is that nice? Yeah, and we want to isolate this right here. We'd love to isolate it. So, hey, look, there's an r right here. Could we just cancel that and that?
What
Sure.
would happen if you had just if you just subtracted r minus 2 and put it onto the other side, so it's r plus 6 minus r minus 2.
You can do that, and then you get rid of the
Is
r
that,
still.
like, mathematically?
Yes, you could have r plus 6 minus r minus 2, sure, equals 4 plus 4 root r minus, sure. But then, look, you have it. What's r minus r? Oh, they're gone. But then you have 6 minus -2 equals 4 plus 4 root r minus 2. What does the left side become, Katie? What's this? That's 8 equals 4 plus 4 root r minus 2. Subtract 4 from both sides. 4 equals 4 root r minus 2. Now what do I divide both sides by? So you end up with 1 is equal to root r minus 2. That's nice because what do you do to both sides?
Square
So 1 is equal to r minus 2. So r equals
2.
3.
Oh my
3.
gosh, I totally did this.
So you take this and you check It's really important that you do. So you end up with the square root of 3 plus 6 minus the square root of, so that's the square root of 9 minus the square root of 1. So that's 3 minus 1, which is?
2.
Does it check?
Yes.
Yay, it does. So you can go in and say it does work. Works. Do first on this one. This will be the last one we do. What do you do first?
Square.
You could square. You could add 3. You could put 3 on the only reason you'd put 3 on the other side would be to get rid of the negative. Like I kind of like making it positive. I would personally, if this was me, I would do this. 3 minus 3p is equal to 3 plus this. It's the same exact thing. I would do it just to get rid of the negative. That's all I would do. Now you square both sides and you end up with 3 minus 3p is equal to 9 plus 6 of these, right? Plus 3p plus 2.
What do you mean 6?
Because you do 3 times this twice because you're squaring both sides.
Yeah.
So I just went straight to 6 because there's 2 3's. Now you need to simplify. On the right hand side, you end up with 11 plus 6 of them plus 3p, and you have the same thing over here. So what can you do here? Oh, it's negative and positive, right? So you add 3p, right?
Subtract 3.
I would subtract 3 and subtract 3. So what do you end up with? 0 is equal to 8 plus 6 of these.
No, wait. If it's plus 3p, then when you subtract it,
No, it's
are
negative.
you trying to get it on
No,
the
we're
other
not.
side?
We're not moving it yet. Not yet. So all I've done is I've combined like terms right now. That's all I've done. Now you want to isolate. So what do you have to do? Subtract 6p and 8. So what do you end up with? Negative 8 minus 6p is equal to 6 root 3p plus 2. What can you divide both sides by? Well, they're all. You could. They're also all even. They're all even. So it could be negative 4 minus 3p is equal to what? 3 of them, right? Now I'm going to divide both sides by 3. So I end up with negative 4 minus 3p all over is equal to this. How many radicals do I have? So what do I do to both sides? So I square this. And now, what land are we in now? We're not in radical land anymore. We're in
Quadratic.
quadratic land, and we love quadratic land.